In the deep silt of an alpine lake, a heavy bomber lay mostly undisturbed for 8 years. The aircraft was a United States Army Air Force's B-17G, later known as Lonesome Polecat. The later recovery would not be a government forensic mission, it would be a private commercial salvage attempt, with the liability carried outside any standing military salvage unit. On March 16, 1944, the B-17G ditched into Lake Zug in neutral Switzerland. The aircraft carried the designation B-17G-30DL and the serial number 42-38160. It was assigned to the 8th Air Force, the 385th Bomb Group, and the 550th Bomb Squadron. Later sources record it under the nickname Lonesome Polecat, though some aircraft databases also preserve the earlier name Little Chub in its assignment history. Following the surface landing, the bomber sank mostly intact. It descended through the water column and settled into the mud at the bottom of the freshwater lake. The airframe then lay largely undisturbed until the private recovery effort began. In 1952, the operational paradigm shifted entirely. Martin Schaffner, a Swiss scrap dealer and local garage operator, initiated a private recovery operation. The motivation was not historical preservation. The goal was to salvage the intact bomber for commercial display. Schaffner intended to exhibit the aircraft to paying crowds to monetize the aviation relic. The problem was procedural, financial, and physical. A massive military structure had to come out of the lake through private means. That commercial endpoint made structural wholeness a business requirement because the aircraft's display value depended on emerging as a recognizable bomber. The recovery concluded successfully on August 25, 1952, after an 8-year gap that turned the wreck into a delayed commercial recovery rather than an immediate post-crash salvage. The delay of 8 years meant the airframe had fully settled into the lakebed sediment. The local environment completely encapsulated the lower sections of the bomber. The recovery operation was entirely dependent on private capital and improvised engineering. A scrap dealer assumed all operational risk. The objective required lifting a heavy bomber from a deep water resting place to a terrestrial exhibition site. No specialized marine salvage vessels were available. No military engineering units were assigned to the lake. The entire operation was conceived and executed as a private enterprise. Without an investigation or personnel recovery mandate, the site functioned as a salvage target, and the private crew carried the burden of heavy industrial lifting. The aircraft was an immense physical object resting in deep sediment. A heavy bomber requires specialized handling even on a paved runway. Underwater and filled with mud, the structure presented an extreme physical challenge. The operation required extracting the machine without compromising the structural integrity needed for a profitable public display. Identification and location were settled. The difficulty lay in the sheer mass of the artifact and the absolute lack of institutional support for its retrieval. The intact survival of the B-17G through the landing sequence was the only reason a commercial display was viable. How did a combat-damaged heavy bomber reach the lakebed still recoverable as a complete aircraft? The physical geometry of an alpine lake presents a strict margin for error when putting down a heavy bomber. For a crew of 10 men, the available options shrank rapidly as the aircraft lost performance. The B-17 sustained heavy combat damage during the Augsburg mission after German fighters attacked the formation near Schwäbisch Gmünd. Reports describe damage to the nose and to 2 engines, with engine number 4 shut down. The loss of power forced a diversion south toward neutral airspace. Maintaining altitude became impossible as the bomber crossed into central Switzerland. The physical constraint was simple. The aircraft was descending toward rugged terrain and populated areas. The commander ordered an evacuation. 9 men parachuted from the failing aircraft near Bar. The bailout sequence cleared most of the crew from the hazardous descent. A fatal failure occurred during this phase when the parachute of navigator Robert L. Williams failed to deploy, resulting in his death. With 9 men out of the aircraft, the operational state shifted entirely. The pilot remained alone at the controls. The immediate decision was a stark operational trade-off. He could abandon the aircraft to crash uncontrolled into the Swiss landscape, risking civilian casualties, or he could attempt a controlled ditching on Lake Zug. He chose to execute an emergency water landing. This decision required threading a heavy aircraft into a confined topographical space. The pilot had to align the wings level with the water while bleeding off airspeed without inducing a stall. The physical survival of the bomber depended on a controlled, low-energy water landing, not on brute luck alone. B-17 ditching guidance emphasized a minimum rate of descent and minimum forward speed, adjusted for wind and wave conditions. On Lake Zug, Meyer brought the bomber down cleanly enough for the airframe to float briefly rather than break apart on impact. The result was not a perfect preservation miracle, but a remarkably successful forced landing that left the aircraft recoverable 8 years later. After impact, the aircraft floated long enough for the pilot to climb onto the wing and accept rescue from local boatmen. The airframe then began to flood. It slipped below the surface and descended into the dark water. The bomber sank to about 45 meters, roughly 150 feet. The structure reached the bottom without breaking apart. Its largely intact state became the clearest physical proof that Meyer's water landing had been controlled, even though the wreck would later suffer damage during recovery. Once on the bottom, a new environmental constraint took over. The aircraft was structurally preserved enough to remain a viable recovery target, but it was still subjected to the chemical realities of submersion. The trade-off of sinking in an alpine lake was extreme lack of accessibility versus better preservation than many saltwater wreck sites. Cold freshwater, limited light, and lower chloride exposure can slow the corrosion of aluminum aircraft structures. It did not stop corrosion altogether, especially in mixed metals and damaged alloy surfaces, but it helped explain why the bomber could still emerge as a recognizable, largely intact aircraft after 8 years underwater. The case remained anomalous because the bomber passed through combat damage, power loss, bailout, water impact, and a 45-meter descent without total structural collapse. Engine number 4 was shut down, but the aircraft also carried additional combat damage, including damage reported to the nose and another engine. That survival created the next question. If the bomber was still recoverable, what blocked immediate salvage efforts? Preparation and permission seeking dictated the pace of this salvage operation. Before heavy cables could be lowered into the deep water, Martin Schaffner had to secure authorization on land. The target was a foreign military aircraft resting inside the sovereign borders of a neutral nation. The salvage team faced a hard operational boundary. The physical depth of the water was only one obstacle. The administrative path through Bern was another. The core constraint was securing permission for a private salvage of an intact warplane. Schaffner initiated the request to extract the heavy bomber for commercial exhibition. That request put the project inside a jurisdictional problem rather than a simple civilian claim. The available accounts describe negotiations and permits, not a simple civilian claim on abandoned property. Approval from Bern became the threshold before physical recovery could begin. For roughly 2 years, Schaffner prepared the project, reconstructed the likely wreck location from photographs and fishermen's accounts, and worked through the necessary permits. The process was unusual because a civilian scrap dealer wanted to raise a foreign combat aircraft from a public lake. The sources support a long preparation and permission phase, but not a formal declassification ceremony or a proven ban on all preliminary investigation. During this period, the project remained weighted toward planning, financing, location work, and permission seeking, rather than full-scale physical recovery. The delay also changed the practical planning burden. Alpine lake work had to be arranged around weather, equipment, divers, surface platforms, and public safety. Eventually, the bureaucratic deadlock broke, and the project moved from permits to force. How could a private team break the physical grip of the lake bed mud? The engineering phase centered on a 33-ton hoisting target and 8 weeks of hard labor on the water. Martin Schaffner and his salvage crew had to design an extraction method utilizing heavy cables and improvised winching gear modified from standard garage equipment. The primary objective was lifting the massive flooded structure vertically from the bottom of the lake to the surface without snapping the lines or buckling the frame. Before the lift could begin, divers had to establish a workable rigging geometry in deep, dark water. The first barrier was not depth alone, but the soft sediment holding major sections of the bomber. On the first major attempt, the cable arrangement did not solve the problem cleanly. Reports describe cables failing and the nose section being damaged or torn away. The operation therefore shifted from a single clean lift into a trial, failure, re-rigging, and renewed lift sequence. The winches ground forward, pulling the heavy cables taut. The salvage team watched the lines carefully because uneven strain could mean another failure instead of a recovery. After the failed attempt, the crew re-rigged the bomber and prepared for a second lift. This time the aircraft came free from the lake bed and began rising toward the surface, still carrying the consequences of 8 years underwater and the damage caused during the earlier pull. The upward transit toward the surface presented a new physical hazard. The bomber was not an empty museum shell. It was a flooded combat aircraft with water, mud, and fuel still inside. Local accounts report that about 1,500 liters of aviation fuel were pumped off during the recovery. That fuel was a real environmental and fire hazard, but the available sources do not support the claim that 16.5 tons of trapped liquid were calculated and managed through a precisely timed pause at the surface. The safer reading is simpler and more dramatic. The crew had to raise a waterlogged aircraft, deal with fuel contamination, and keep the fragile, damaged structure under control as it emerged from the lake. The controlled recovery effort reduced the immediate hazards enough for the lift to continue. The cables held and the winches brought the massive bomber out of the water. The roughly 2-month physical operation reached its climax in late August 1952. The aircraft was raised from Lake Zug and then brought ashore near Zug with local industrial assistance. It was a technical success, but not a flawless extraction. The earlier nose damage still had to be corrected afterward. The airframe now sat on dry land, largely intact but no longer untouched. Once ashore, how could a heavy bomber be moved through narrow Swiss infrastructure? The successful extraction of the aircraft created a new operational trade-off. Leaving the bomber assembled made it a spectacular attraction at the lakeshore, but any longer overland journey required cutting its footprint down to something roads and railways could handle. Martin Schaffner now possessed a recovered heavy bomber resting near Zug. The recovery now had to pay for itself through display, and that economic pressure shaped every subsequent handling decision. The exhibition plan collided with Swiss roads and railways. A complete B-17G was built for airfields, and its wingspan made ordinary overland movement impossible. The mechanics therefore reduced the aircraft into transportable sections. Wings, tail surfaces, engines, and other assemblies could be separated, loaded, and moved by road or rail depending on the destination. The logistical trade-off was successful. The team exchanged structural wholeness for terrestrial mobility, ensuring the artifact could reach its intended market. Once the sections moved, the tour began. The aircraft drew crowds first around Zug and then at later exhibition sites across Switzerland, including Cham, Basel, Biel-Buzzingen, Lausanne, Bern-Bümpliz, and Sur. After Schaffner's death in 1965, the bomber's story continued under later owners and display arrangements. It was shown at St. Gallen Winkeln in 1966 and moved to St. Moritz Bad in 1970. These later moves were not simply a convoy of trucks through mountain roads. At least part of the St. Moritz move involved rail transport before final road movement. The exhibit remained spectacular, but every relocation required disassembly, heavy handling, money, and space. As the initial novelty of the recovery waned, the bomber's size shifted from commercial asset to financial liability. With the airframe heavily exhibited across the country, what economic reality ultimately doomed the artifact? On dry land, the bomber faced a different enemy: space. About 2 decades after its extraction, the commercial exhibition life of the bomber reached its end. The novelty of the recovered aircraft diminished, and the cost of moving, storing, and displaying such a massive machine became harder to justify. By then, Schaffner was no longer alive, and the aircraft had passed through later private hands. No state aviation museum absorbed the whole airframe into a protected national collection. The massive bomber was left exposed to the open commercial market, dependent on owners who still had to solve the same problem Schaffner had created: where to keep a 4-engine bomber. The terminal scrapping of heavy historical hardware is dictated by the absolute economic trade-off between a static footprint and land development potential. A 4-engine bomber occupies a large, flat expanse of land. In a developing municipal area, that same square footage holds massive capital value if repurposed for residential or commercial construction. When an artifact lacks legal heritage protection, its structural survival is entirely dependent on a landowner willing to absorb the opportunity cost of not developing the site. As land values rise, the artifact becomes a physical obstruction to capital generation. By the early 1970s, the aircraft was no longer simply Schaffner's lakeside trophy. It had been displayed at St. Gallen Winkeln and then at St. Moritz Bad, where its final chapter unfolded. The economic equation became unforgiving. The bomber was too large, too expensive to house, and too difficult to preserve without a buyer or institution willing to take responsibility for it. Local accounts describe it as having to make way for new development, and with no solvent rescue appearing, the aircraft's remaining value collapsed towards scrap and clearance. In or around 1972, the airframe was subjected to terminal scrapping at St. Moritz Bad, with some later databases recording the final disposal as 1973. The heavy structure that had been raised from Lake Zug, toured across Switzerland, and repeatedly reassembled was cut apart. This was not a careful museum deaccession or a preservation-minded dismantling. It was the end of the aircraft as a complete structure. Only scattered parts survived afterward, including detached components and fragments that later reached museums or private collections. The central objective of the initial private recovery operation had been a practical success, proving that an improvised Swiss team could retrieve a largely intact heavy bomber from deep water for commercial display. But without long-term institutional protection, the airframe could not survive its own size, cost, and mobility problem. The complete aircraft known as Lonesome Polecat was lost not in the lake but on land.